Hello and welcome to the class. Steve's Tech Tube here, and we're going to cover MicroLogix PLC programming using the free RSLogix Micro Starter program. First, I'd like to start out and just kind of talk a little bit about what is a PLC. I'm not going to make any assumptions here that you've had a background in PLC programming. Perhaps some of you have, some of you haven't. If you have, feel free to skip forward if you'd like. But I'd like to talk about what is a PLC. Basically, a PLC is a programmable logic controller. They're very important industrial automation. There's some differences. You may have heard of PLCs, some other types of control systems. Um, in overview here, it's really an industrial computer that's designed to automate processes, machinery, and equipment in a wide range of industries, such as manufacturing, energy, and transportation. PLCs are widely used because they're very reliable, durable, and flexible for various automation tasks. Some of the key features All right, some of the key features of PLCs, some of their control capabilities. PLCs monitor inputs. Inputs are things like sensors and switches, and they also control outputs, things like motors and lights. And they controls these things based on user-defined logic. PLCs execute repetitive tasks with really high precision. Things like starting and stopping of machines, controlling conveyor belts, and also things like regulating temperature. Um, a programmable controller is an industrial computer. It's designed to automate processes. All right, so this is kind of a strange example of one here, not really the best, but it kind of gives you an idea of you got inputs that are wired, outputs that are wired. Inputs, this could be your sensors, switches, photo eyes, things like that. Outputs could be motors, lights, solenoids. Now, for programming, PLCs use specialized programming languages. A common one that's been used for many years is ladder logic. That's actually what we're going to be focused on here in this class. But there's also structured text and also function block diagrams. Ladder logic's still the most common, and it's designed to mimic electrical relay logic diagrams for ease of use. Back in the day before PLCs, you might find old control enclosures full of relays, just hardwired relays. And so PLCs have been able to replace these very large relay control systems. One thing about PLCs, they have a modular design. They're modular, which allows users to add or remove components, such as input and output modules, power supplies, also communication modules. There's a lot of the PLCs now, they communicate over Ethernet. There's lots of other communication protocols, but ones that are based on Ethernet are most common today. PLCs are very reliable. They're meant to be in harsh industrial environments. They're pretty resistant to dust, heat, vibrations, and even electrical noise. And also PLCs, they can perform tasks in real time, which ensures that you have, rapid responses. If you've got a process that's changing rapidly, you need a controller that can keep up with that. Now, some of the components, basic components, would be things like your CPU, which is the central processing unit. It's really the brain of the PLC, and it handles the processing of the inputs and executes the logic and also updates the outputs. And then you have your inputs, which are devices such as your sensors, switches, push buttons that send signals to the PLC. Um, you also have outputs. Outputs would be things like your motors, solenoids, or lights that the PLC controls based on the program. The program is what's going to decide what needs to be turned on or off. And the power supply, which provides power to the PLC and its components. You need to have enough power to program to power up the CPU, but also enough power to drive all the outputs that you might have. And then you've got communication ports, which allow that PLC to connect to other systems. You might have HMIs. HMIs just stands for Human Machine Interface. It'd be your display like a touch screen. Also SCADA, which stands for Supervisory Control and Data Acquisition. You've got a lot of SCADA systems out there. I'm familiar with like GE iFix. There's Wonderware, also Ignition from inductive automation. That's a really good SCADA type system, or even other PLCs. You can have large systems with multiple PLCs that need to communicate together. Some of the applications of PLCs, manufacturing is a big place where you're going to find these things like assembly lines, could be automotive, basically anywhere, packaging systems, even robotic arms, possibly, controlled through PLCs. You've got, process control, things like temperature regulation, chemical processing. I've done work in all these, chemical processing, food production. I've had to do PID control, proportional integral derivative, that uh, controlling things based on temperature, transportation. You've got elevator systems, traffic signal control. We're actually going to have an example towards the end of this class where we're going to actually do just a mock traffic signal control for 4 traffic signals at a, north, south, east, west intersection. Things like railway signaling. Also, you've got, energy applications for power distribution, wind turbines, solar panel monitoring, and so on. So quite a wide range of applications. And really, why would somebody want to use a PLC? Well, you've got, for one thing, they're pretty flexible. A single PLC can control, a number of systems with reprogrammable logic. I mean, you can always go in and change a program to, perform a new task. So if you got to update, change a machine, it's much easier to go in and change a program in a PLC as long as you have enough inputs and outputs to handle any new devices. Much easier than trying to rewire or add relays to a relay control panel. It was a lot more difficult many years ago. Also, PLCs are cost effective. It reduces the need for complex hardwired systems. Scalability, they're modular. So a lot of PLCs you can expand, you can add modules, add more inputs, add more outputs as needed. You can have, remote I/O. You can have a central processor, a local rack, and you may have remote I/O in another part of the building that's all tied into that same controller. So it's very, very flexible and the scalability is very important. There also ease of maintenance. There's diagnostic tools to help troubleshoot errors quickly. And really, the PLCs are the backbone of modern industrial automation. It enables businesses to improve their efficiency, reduce downtime, and also enhance their productivity. So I want to talk a little bit about some of the differences between PLCs and some other control systems that are out there. PLCs versus microcontrollers. PLCs are designed for industrial automation. Microcontrollers, those are more for embedded systems. You've got some consumer electronics, automotive, etc. As far as ease of use, PLCs, I would say the very user-friendly type programming. Of course, it depends on the PLC. You have to be familiar with that brand. There are differences between Rockwell, Mitsubishi, companies like Omron. They all have their own programming software, but ladder logic is somewhat similar. Microcontrollers, it's going to require knowledge of low-level programming languages like C or assembly, and so on. PLCs are really durable. They're made to withstand harsh environments, heat, dust, vibrations, but microcontroller, they're not as rugged. It really requires additional housing. You have to have special housing for those if you want to use a microcontroller in an industrial setting. As far as real-time operations, for a microcontroller, really depends a lot on the programming and hardware. They're not always deterministic. It really depends. But really, PLCs, those are designed specifically for deterministic real-time control. That's where they shine, and that's really what they're meant for. And as far as expandability goes, I'd say that a microcontroller is very limited I/O. They're usually a lot less modular, whereas PLCs, they're built to be modular with add-on I/O modules. So it's really easy to add additional inputs and outputs. You may have heard of DCS or distributed control systems. Um, the scope of those, normally a PLC is meant to control a specific machine, usually one machine or maybe a small subsystem. A distributed control system, a DCS, sometimes those will control and manage an entire plant or process, maybe like with oil refineries, chemical plants, possibly even some pharmaceutical applications. I've seen, DCS systems used there. The architecture, as far as architecture goes, PLCs are really centralized, or at least semi-centralized. They're designed for machine level automation, whereas the DCS is decentralized. So a DCS system will have multiple controllers where they're managing different process areas. And now programming is going to be a little different. With PLCs, you've got ladder logic, and there's other specific languages like, you've got the function block, structured text. With a DCS, that uses some advanced control strategies and algorithms that are more tailored towards process control, so not really the same type of programming. And scaling, PLCs are great for small to medium automation tasks. A DCS is really for a large scale, continuous type process, which you're going to find a lot in chemical plants, refineries, things like that. The cost wise, a PLC is really cost effective for a smaller system. DCS can be a lot more expensive, but it's really better suited for those large scale processes. So it really depends on what you're doing, where you'd really want to get involved in these. And then, of course, this one here should be pretty easy. PLC versus hardwired system. I don't even think I really need to read through all these. I mean, hardwired systems are very rigid. Anytime you want to make a change, you got to physically rewire circuits. Complexity very limited to simple tasks, basic on-off controls. Troubleshooting is manual, time-consuming. You're going to be using your meters a lot, trying to measure voltages and currents. Space requirements, huge panels. If you've ever seen a really old system with very large, panels for relays and wiring, and then of course very, very expensive to maintain over time. And the PLC just, wins hand down on every category with that. Um, SCADA, I see a lot of systems that actually combine the two together. You have a PLC and a SCADA system doing, a lot of times if you're doing things with a SQL database, SCADA systems can be really good with interfacing with that. The PLC can be concentrating on machine level tasks. The SCADA system can do a lot of supervisory work. But, communication wise, SCADA systems often rely on PLCs to actually execute commands and control the actual hardware. So again, the role SCADA systems it's more of a supervisory system for monitoring data acquisition and operator interactions, things like that. But the PLC really acts as the controller for the real-time automation tasks. The SCADA is more high level. Um, the PLC is more hardware focused with programming for specific hardware related tasks. And really, the SCADA is more focused on providing visualization and data analysis of a system. So that's really most of the differences there. Um, I guess in summary, I'd just say, PLCs are really rugged, they're reliable, They're specifically designed for industrial automation at the machine level or subsystem level. Other systems like microcontrollers, DCS, SCADA, they've got their own strengths in different areas. Again, microcontrollers are cost effective for an embedded system. DCS excels in very large scale process control. SCADA provides supervisory level control and data management, but I would have to say, SCADA systems are often tied in with a PLC because in a lot of cases you're still controlling things on a machine hardware level, and that's where the PLC excels. And a PLC mixed with a SCADA system is a really common system to find. Hardware systems are really limited, and they were kind of the foundation of very early automation, but you're not really going to find that very much anymore. That's really outdated, been really replaced through by PLCs over time. PLCs really they bridge the gap between complexity and practicality, and really it makes them a go-to choice, I'd say, for most industrial automation applications.